right, today we're going to look at wave, tides, and currents. We're going to go in between. I've got some different video clips to show you, so we'll pause while we're taking notes and watch each of those. So we're going to start today by just some definitions and then think about how these different movements within the water interact the ocean. And we're going to start with a wave, and a wave is just a movement of energy through the water. And the size of the wave is always determined by its strength. So is it blowing at 5 miles an hour? Is it blowing at 50 miles an hour? And if you think about the recent blizzard in the Northeast, the higher winds are what create that as a blizzard coming off the ocean. And the length of time that it blows. Is it blowing in short bursts? Is it a steady wind? And so energy is moving toward the shore, but the water is remaining in place. And I know that's rather a hard concept. And we're going to pause here, and I'm going to borrow some of you to kind of demonstrate how the energy is moving toward the shoreline, but the water is remaining in place. So as the wave energy gets closer and closer to the shoreline, the height of the wave is going to increase, and the length of the wave, the distance between the two crests, is going to decrease. And you're running out of seafloor, and then you've noticed the wave just kind of falls over on the edge of the beach. And in a tsunami, the energy is coming from an underwater earthquake, and that slipping and shifting of the rock layers is releasing a tremendous amount of energy. And so as that energy passes through the water, it creates this wall of water, and as the wall of water gets closer and closer to the shore, it collapses onto the shore, and you create great loss and damage. If you want to think about the Christmas Day tsunami several years ago in Indonesia, and how that great wall of water, as it moved inland, just collapsed over those very slim islands and wreaked havoc. Waves, as they come into a beach, create erosion and deposition. During calm water, waves will just drop any sand they're carrying in the water. During storms, when you've got higher winds and much more energy, as the waves are higher, and they're going to actually carve up the beach and remove sand, so deposition is occurring. Now, another phenomena when you were talking about oceans is the tides. And tides are caused by the interaction of the gravity of the earth, moon, and the sun. And we have high tides and low tides. And in a high tide, the pull is greater, and the water will come farther up on the shoreline. In low tide, the pull is less, and the tides change 4 times a day. So you have 2 high tides and 2 low tides. And if you have 2 high tides and 2 low tides, then that means they're changing about every 6 hours. And there are different types of tides that occur as well. We have spring and neap tides that occur, and we'll talk about those in a minute. But we're going to pause here, and we're going to look at 2 video clips. We're going to look at the Bay of Fundy, which has some of the most phenomenal tides and the greatest difference between high and low tide each day because of the shape of the bay, and I want to show you that. And then I want to show you that wave energy is a possible renewable source of energy that we can use in the future, and how can we harness that wave energy. And I'll let you see this little short clip about how some research that's being done on that. So we'll pause for a second. All right, so a spring tide occurs. We know the moon, we see the moon in different phases: full moon, crescent moon, new moon, where we don't see the moon at all, half moon. And when the earth, moon, and sun are in a horizontal alliance, and you've got this greatest distance now between your high and your low tide. So at least once a month you're going to have a spring tide where the high tide is going to go even farther up the beach because of this alignment of the earth, sun, and moon. And the pull of gravity is going to be greater. And if that spring tide occurs during a full moon, you have even a larger spring tide or a larger distance between high and low tide. The neap tide is where you have the least distance between the waterline of high and low tide, and it's going to occur when the sun, moon, and earth are at a right angle relationship, and so there's not going to be quite as much difference in each of those 6-hour changes. Now, currents you can think of as kind of like a river of water moving within the larger body of water. And I'm sure some of you have been on the beach and, you plopped all your stuff down and you go out and you play in the water, and then you look up and your stuff, you will move 10, 20 feet away, because that's the pull of a current pulling you down the beach. And so there's several different types of currents going on. There's rip currents, which can occur a lot off our coastline because we have so many sandbars and the water gets pulled between the sandbars, and they're the ones that can pull you out and can be very dangerous to swimmers. Then we have the longshore current, which runs north to south in North Carolina, and that's the one that pulls you down the beach from where you left your stuff, and so it's pulling you south. And then we have large surface currents that are climatic event occurring, and that is called El Nino, and it occurs every 2 to 7 years in the Pacific. It's an unusual pattern of winds due to, again, warm water moving toward South America, and it can create weather problems worldwide. And so sometimes you'll hear them talking about them on the news about El Nino events. I remember one year, right after I came to Daniels, when we had recess like we do now, and it was an El Nino year. And here, that's happened in the Pacific, but we were impacted on the East Coast with high rain. And due to the amount of rain we had, we did not go out for recess the entire month of January and February, because if it wasn't raining, it wasn't really that cold, but if it wasn't raining, the fields were just so muddy, we couldn't go out. So we stayed inside for 2 months. Now, there's another current going on in the ocean, and that is deep water currents. And deep water currents flow from the poles to the equator, so you've got one moving northward toward the North Pole and back to the equator, and then you have deep water currents moving from the equator to the South Pole and back. And these are caused by density differences, and it takes 1,000 or more years for these currents where the water begins, say, at the equator, before it gets to the poles and comes back. And we know that cold water is more dense than warm water, so you've got this movement of water, this sinking and rising of water within the deeper waters. And so surface currents are caused by winds, and deep water currents are caused by density differences, density difference between hot and cold water. And cold water is also saltier. The salt water sinks, and so that's another factor. And then depth. You're going to have these deep water currents are going to be in your deeper waters because it is going to be colder because of the lack of sunlight. Now, upwellings are very important in the marine food chain because as animals and plants in the water die, it sinks to the bottom, and this detritus or dead dying material, as it decays, it actually acts like fertilizer for the phytoplankton. And phytoplankton is the main producer in the ocean food chain. And upwellings, as the movement of cold water gets pushed into the surface out in the, and I'm talking about to the very top, but to more surface waters, as that comes out in the open ocean, they're going to bring up this dead, decaying nutrient matter from the seafloor. And that's going to act as fertilizer for phytoplankton. So you're going to have these mass blooms of phytoplankton, and then you're going to have small fish and zooplankton all moving toward this phytoplankton bloom. And then if there's small fish there, it's going to bring larger fish and even larger fish. So upwellings are going to be areas which are great for fishermen. It's where you're going to have a lot of activity in the marine food webs going on near upwellings, because fish are going to follow this nutrient matter, because there's going to be a lot of phytoplankton, zooplankton, and small fish there, because food loves food. Or food follows food, I should say, in the marine food web. So the decomposing matter acts like nutrients, and we know that bacteria are responsible for that decomposing, but it acts as fertilizer for plants, and then that will feed the small organisms, and then the herbivores, and then that will feed the carnivores, and on up the food chain to your large game fish. So fishermen really love to find the upwellings in the ocean. So we're going to stop here, and that's going to be the end of video 4.